this is Captain Chaudhary. Today I'm going to speak about some special kind of problems from chart work. This numerical is, in my opinion, a funny numerical. You have so many land objects available. Why do you go for such an exercise? Well, in this question, what is important is you have three observations made at three different times. Three observations at three different times, out of which the middle observation could be a distance from a light or bearing from a light, whereas the initial and final observations are the bearings. These bearings, which are initial and final bearings, that means say in a matter of say 45 minutes, if the first observation is taken at certain time, second observation after 15 minutes, and third observation say after 30 minutes. So the gap is in the ratio of 1:2. So I told you the middle observation could be a bearing or distance. The first and last are the bearings. These bearings cannot be parallel. These cannot be parallel bearings. These bearings have to be converging or diverging. They will not be parallel. So let us say we are coasting, and here is this is the first bearing, say at 1900, and this is the last bearing, say at 1945, and the middle information could be bearing or distance, and as I said, the middle information is at 1915. Course is given, say this is the direction of course. Course steer is given, and you are also given engine speed. Say course steer maybe 250. Speed, say it is 12 knots. And there are these three information: 1900 and 1915 and 1945. Middle information, I will put it down a little later. The middle information is at 1915. The ratio between the observations, the gap between the observations is 15 minutes and 30 minutes. The ratio is 1:2. So what we need to do in these kind of questions is we transfer the first bearing forward and last bearing backwards, right? Transfer the first bearing forward and last bearing backwards till the middle information. Middle information is at 1915. That means I will transfer this bearing line forward by 15 minutes, transfer this line backwards by 30 minutes along the engine speed. Normally the transfer is done along two arrow line or course made good. Here in this particular numerical, the transfer is along the course line but at engine speed or the speed over water. So 12 knots in 15 minutes, it is 3 miles in 15 minutes. So let me transfer this line forward by 15 minutes. I can put two arrows here, and I want to transfer this line backwards, so it appears like this, double arrow. And what I tell the students that I've got the first intersection between the transferred lines. This line transferred forward by 15 minutes, this line transferred backwards by 30 minutes. I get first intersection point. Now, the importance of this intersection point is if the ship's course was on this line and if there was no current, I would have been going from here to here, because this point can also be called as no current point. In fact, on the diverging side of this point, you have favorable current zone, and on the converging side of this point, you have against current zone. Now, you can see in this question, the direction of current is 290, which is forward of the beam, which is setting forward of the beam. So it is a favorable current. If it is a favorable current, then my ship should be in diverging zone. And if the current was against, say for example, if the current was 040 or something like that, then my ship would have been in the converging zone. So the student has to decide at this stage that the current is favorable, so most likely I am going to be south of this position. So what you can do is select a point well south of this intersection point and put your course steered. So this is the course steered, and then along the current, along the direction, in the direction where the current is setting, put the current with a random range, with a random drift. We don't know the drift, we don't know the rate of drift, but from the first transferred line till the second transferred line, you can put the 3 arrow line, that is the current line, and once again put your course, the second transferred line till third bearing. So from the first bearing till the transferred line, you came by course steer, then 3 arrow line, and once again 1 arrow line. Now what you have got is the shape of Z. Basically this exercise I am doing in the diverging section, because I know the ship is somewhere south of this point. Now this exercise is done basically to divide the drift line in the ratio of 1:2 once again. It means if I draw a diagonal like this, then this diagonal divides the drift line in the ratio of 1:2. 1:2. You can see that. This is a geometrical exercise done to divide this drift line in the ratio of 1:2. Now I have got second intersection point. I've got the second intersection point. If I join the first intersection point with the second intersection point, this is like a line that divides the entire zone in the ratio of 1:2. Can you see that? As if the entire zone is divided in the ratio of 1:2. Now this is also a line on which the ship should be at the time of second observation, that is 1915. And let us say in this particular question I have not plotted 1915 bearing. Suppose the 1915 bearing was this. Suppose this was the bearing at 1915. If this was the bearing at 1915, ship had to be somewhere on this line at 1915. Ship is also on this line at 1915. So this is the position of the ship at 1915. This is 1915 position. Now once we have got a 1915 position, what should we transfer through this position? Should we transfer this particular line? What is this line basically? Basically this line is nothing. This line is not course made good line. This is not course made good line because the current here is not for 45 minutes. So this is just a line which was drawn to divide the drift line in the ratio of 1:2. It is not 2 arrow line. So what can be transferred through this point for the first time is the current itself. The current is transferred over here, and once again draw this shape of Z, which would be like this and like this. So basically what you have drawn here is 15 minutes course steered, course made good triangle, and over here you have 30 minutes course steered, course made good triangle. Actually this is the direction of course made good, and ship would advance on this line physically. So what we have got here is the course made good direction, and what we have got here is the drift for 45 minutes. If this is the drift for 45 minutes, you multiply this by 60, divide by 45, you will get rate of drift. So this is how we do this zigzag exercise, or fish triangle exercise as the boys call this exercise. And the significance of this is to find the position, to find the rate of drift when 3 observations are given at a known interval on a steady course. So this was the exercise when the current was favorable. Now we will do the exercise when the current is against. The current is not favorable. Once again, we have three observations. We have course steer. We have to find out a rate of drift. We have engine speed also with us. Three observations. So those three observations once again should be in the same pattern as last question, and the first and last bearing, they cannot be parallel. Now let us say this bearing was taken at 1900 and middle information was at 1924, and say the last information was at 1954. So we have the gap between them in the ratio of 24 is to 30, that is 4:5. Now the current is against. Current is against because let's say that the ship's course is something like 124 at 12 knots, and as we go on 124, there is a current that is against, that is 240. 240 degrees is the direction of current. So once again, we are going this way. We'll at any point that we want, we can put course steer being 124 degrees. This is a course steer. I've just drawn the course steer. I've just drawn the course steer randomly, and now what I intend to do is transfer the first bearing forward. This is 1954 and this is 1900. What I want to do is I want to transfer 1900 bearing forward along the course steer and speed over water for 24 minutes and transfer this line backwards for 30 minutes. So if you're going at 12 knots, 4.8 miles will be the forward transfer. For 30 minutes, the transfer will be 6 miles. So this is 6 miles, 30 minutes, and this is 4.8 miles along the coastline and at the rate of engine speed. So what we have done is we have transferred the first line forward and last line backward for 24 minutes and 30 minutes respectively. So I get the first intersection point. Now after getting the first intersection point, the candidate has to understand that the current is not favorable, current is against. This is the no current point. So the ship would have gone from first bearing to third bearing in a position north of this point, not south of, because south is diverging, north is converging. The distance between the first bearing line and last bearing line should be less than what you would get at 12 knots, right? So we will select a point as close as possible to the lines because we know that the ship is in converging zone. So once again, we will draw the course steer, right? So once again, we will draw this course steer till the first transferred line, and from the first transferred line till the second transferred line, we come back along the current. Current is against, and once again we will draw the course steer. So from the first bearing line to first transferred along course steer, from first transferred to second transferred along the current, and from second transferred to the last bearing along the course steer once again. So we get a shape of Z. Now the shape of Z is there, and we will meet the endpoints or the diagonal. This is an exercise to divide the drift line in the ratio of 4:5. So if this is 4 units, this would be 5 units. And this way we also get another intersection point. I've got one more intersection point. This was the first intersection point. Now when I join the two intersection points and extend the line in both directions, this is like a ratio line dividing. This is like a ratio line dividing the zone in the ratio of 4:5, right? So what happens is this also acts like a position line. Now I have not plotted 1924 bearing, which is intermediate bearing. Wherever the 1924 bearing, say for example, if this was the 1924 bearing, 1924, wherever this 1924 bearing meets the ratio line, that should be the fix. So this is the fix at 1924. The first thing that I would transfer through this fix is the current line, and having drawn the current line, I will draw a similar Z. This is the coast steer and this is also the coast steer, and when I join the ends, the diagonal represents the actual course made good. So this is the actual course made good of the ship, and this actual course made good of the ship has to be on the converging side of the no intersection point. So this is how you would do a plot. This is how you would do this exercise when the current is against. To find missing course. Now there could be three kinds of questions under this, right? Let us first understand what are those three kinds. The first type is where initial position is given, and the second one is final position is given, and the third type is both positions are given. What is the general philosophy behind these questions? The philosophy which is used in these kind of questions is something like day's work, whereby we have several courses that is traversed by the ship. If we change the order of the course, like if the first course is put in third row and third course is put in first row, the final delat and departure will not change. That is a principle basically we use here. So what happens is the known courses are put towards the fixed side. Like consider this one and this one. Here the initial position is given and final bearing is given. Here final position is given and initial bearing is given. So what we can do is basically all the known courses can be placed in the beginning where we know the initial position, and in this particular category the known course is cut and paste and switched over the final position. Unknown segment is treated with the bearing that is given. Now the set and rate also can be considered as one of the courses and distances. That means one of the rows of the day's work. Let us take this example where initial position is given. You have a lighthouse and you have initial position. Say this is at 1700 hours. Right? Now you steer a course of say 120 into 10 miles, and then the course was altered to port. We don't know what is the course, and you steered that course for 12 miles. In 2 hours, the current set say 120 degrees true, and the total drift was say 6 miles. So basically if we consider these as the various courses which we apply in day's work, this is the segment that we know fully. This is also the segment we know fully, but this particular segment where you altered course to port and you steered for 12 miles, we do not know the segment completely. So this particular segment has to be left. We will treat this segment with the bearing that was taken. So all the known things can be placed here. For example, you could put this course here, you could put this set and drift also over here, whatever you want. Say, let us say we put this segment 120 into 10 miles. And then let's take the current as 180 degrees true into 6 miles. So we can put that current segment also over here. Now compared to this course that was steered, the vessel altered to port, right? And then probably over here there was the bearing that was known at the second observation, that is 1900 hours. So we have plotted this bearing of 1900 hours. From this position, what we can do is we can put an arc of 12 miles. So if we cut an arc of 12 miles from here, it probably would cut here. This is the unknown course. This is the missing course. So this is how we can find out what was the missing course. Once again, in this particular question, we are given the initial position and we are given the final bearing, right? So the principle that we would use is, if we shift the order and all the known courses, if we place on the fixed side, so the first known course that we had was 120 into 10 miles. And the second known thing that we had is the current, which was setting 180 degrees, and total drift for 2 hours was 6 miles, right? Now the unknown thing was a 12-mile segment. We don't know the course, but we know the distance traveled was 12 miles, and the last bearing that was taken is plotted. Now from this position, right, from the end of drift, if we cut an arc of 12 miles, it cuts here. So this must be the missing course. Now to find out how exactly the vessel must have traversed, the vessel steered this course. She experienced this current for 1 hour. This would have been the course made good. The ship actually traversed through this 2-arrow line. From here, the ship would have steered this course. Ship would have come to a position like this, and from there the drift would have brought the ship down to the fix. So this is how the ship actually traveled in these 2 hours. Okay, so any intermediate position also can be found out. Like ship was here at 1700, ship was here at 1800, estimated position 1800, and ship was here at 1900.